Hello and welcome to the course on design of machine elements. So today we will see some numericals on Spur Gear design. So the first numerical is like this. You have been provided this particular data to calculate few parameters in the Spur Gear design. So let us read this particular numerical first. A pair of spur gear with 20-degree pressure angle. So you will be given a pressure angle which is 20 degree, and the pinion consists of 25 teeth while the gear consists of 60 teeth. So pinion teeth and gear teeth is specified and pressure angle. Then the module for this particular gear is 5 mm while the face width is 45 mm. So this more data is given about module and face width. Then it is said that the pinion is rotating at 500 rpm. So pinion rpm is 500, and this gear pair is made up of a steel having SUT 600 Newton per mm square, and these gears are heat treated to a surface hardness of 220 bhn. So material for pinion as well as for the gear is same, and you have to assume the dynamic load accounted by velocity factor. So you have to use the velocity factor to calculate the dynamic load in this particular problem, and the service factor and factor safety are given as 1.75 and 2, while the load distribution factor is given as unity, and you are asked to calculate the strength, gear strength, and the static load that the gear can transmit, as well as you have to find out the rated power that can be transmitted by gear. So this data is given for you so that you can make use of this data to complete these calculations. The load stress factor K is given by 0.16 into Bhn by 100 bracket square, and the Lewis form factor equation is 0.484 minus 2.87 by Z. So if you are calculating it for pinion, so accordingly here you are going to use the number of teeth on the pinion, and if you are calculating for gear, it will be Zg here. So, and the velocity factor Kv is given as 3 upon 3 plus V. So first thing is that we have to note down the given data carefully. So as we have just now discussed on the statement that pressure angle is 20, number of teeth on pinion is 25, number of teeth on gear is 60, while the pinion is rotating with 500 rpm, and this gear pair is having SUT of 600 Newton per mm square and Bhn 220, while the module is 5 mm and the face width is 45 mm, and the application factor or service factor is 1.75. we are using notation Ka for this. Factor of safety is 2, notation Nf for this, and load distribution factor, that is 1, as it is said, it is unity. As you are going to calculate the dynamic load by using the velocity factor, so velocity factor is specified in the problem statement, that is 3 upon 3 plus V, and these are the things that you have to calculate: beam strength, gear strength, static load that the gear can transmit, and the rated power that can be transferred by this gear. So first we will try to find out the beam strength of this. So this is the equation for beam strength of gear tooth, which is given by SB is equal to sigma B into B into M into Y, where sigma B is the bending stress, B is the face width, M is the module, and Y is the Lewis form factor. So as we have seen that in the statement itself it is given that material for pinion and gear is same. So when it is same for both pinion and gear, then the pinion will be weaker than the gear in bending. Sometimes the material may be different, so if the different material is there, in that case you have to calculate the product of sigma B and Y to check which particular product is less. So whichever is less, that will be weaker, and you have to consider that beam strength either of pinion or of the gear, whichever is weaker. So here the sigma B we are not going to compare because it is same, so we will just compare the Yp and Yg values. So always the Yp value will be less than the Yg, as number of teeth for the pinion are less than the number of teeth on the gear, and therefore we are calculating the beam strength for pinion of that particular spur gear. So this is the equation that can be written for beam strength of pinion. So sigma B into M into Y. So we will calculate bending stress first. So that is SUT by 3. So 600 divided by 3, that is 200. Face width is given 45, module is 5 mm, and now we will calculate the Lewis form factor, which is given by this equation 0.484 minus 2.87 by Z. So if I put the value of this ZP here 25, I will be getting this YP as 0.369. So after putting all these values into the equation of SB, if I multiply all these values, 4 terms are there. So just put these values here and getting this particular value as 16614 Newton. That is the beam strength of this pinion. Now we have to calculate the wear strength. Second step is to calculate the wear strength of this gear pair. So as pinion and gear have relative motion between them, so the wear strength will be for a pair in contact. It is not either for pinion or gear, it is for the pair in contact. So the wear strength equation of a gear tooth is given by SW is equal to dP into V into Q into K, where dP is the pitch circle diameter for the pinion. So it is M into ZP, module is 5, number of teeth on pinion is 25, so it is 125 mm. Face width is 45 mm, it is given itself in the statement. Q is the ratio factor, so it is external gear pair, so it is 2 into ZG upon ZG plus ZP. If I put this value of ZG and ZP here in this equation, I will get this ratio factor as 1.41. Then load stress factor, so it is given by 0.16 into BHN by 100 bracket square. So you simply have to put the value of BHN here. I will be getting this value as 0.7744. So once we get all these values, now we have to put this wear strength equation here and put all these values into this particular equation. So dP, B, Q, K, these values are going to put here 125, 45, 141.1 and 0.7744. So multiplying these all, you will get 6141.96 Newton as the value of the wear strength. Now you have to find out the static load that the gear can transmit. So as we have calculated the beam strength and the wear strength, so we observed that the wear strength is less than the beam strength, and therefore when you are going to use the design equation here, so in that design equation we are equating the product of effective load into factor safety with the minimum of FB, SB and SW. So minimum of SW and SB, if we compare, so we found out that here wear strength is less, and therefore this SW is put over here. So this effective force we are going to calculate by using approximate method using velocity factor. So in that case it is given by K into Km into Ft divided by Kv. So this is nothing but the application factor, load distribution factor, this is tangential force, okay, and this is velocity factor. This is nothing but multiplied by factor of safety equal to wear strength. So simply we are putting in those values which are available to us in the statement. It is given already. So here you will find out that after putting these values, you will observe that these two unknowns are there still, Ft and Kv. So let us calculate Kv because Kv depends on velocity. So we have to calculate velocity first in meter per second using pi into dP into np by 60,000, and then put this value of V into this equation of Kv, and once you get that Kv, you can put it over here and get the value of tangential force acting on this particular gear tooth, and that is nothing but the static load that the gear can transmit. It is actually rated load. And once we get this, we can find out the last step of this particular problem, that is rated power that can be transmitted. So power is equal to force into velocity. So tangential force we calculated and velocity also we calculated. So product of this will be giving us the power in watts. So divided by 1000, you will be getting this power in kilowatts, that is 2.74 kilowatts. So this is the way you can solve this particular numerical. You can also try to solve one more numerical which is just specified over here. Okay, so try to solve this and see how you will get the answers to this. Actually this statement and the previous statement which you have seen is just similar to that. Only thing is that the way the statement is given here, it is different. It means in this case directly they have asked the rated power that the gear can transmit. So for this definitely you have to calculate the beam strength first, then wear strength, and then tangential load, and finally rated power. So thank you very much.